because piecewise functions are still a function, sometimes you'll be asked to find the domain and range of them. Now, we've already looked at key features, so that concept has not changed. So domain is still all possible x values of a function, where range is all possible y values of a function. Again, piecewise functions is just a big function made up of two smaller pieces. So that's what I'm going to put in these boxes this time. 3x minus 1 when x is between -2 and 2. And it's the function -2x plus 4 when x is between 2 and 5. Okay, so none of this has changed, right? If we can graph this, it'll be a lot easier to talk about than trying to find domain, trying to find range of equations. So a of x equals 3x minus 1. So I get this red graph. Then I type in my inequality, -2. X is greater than that. And then x is less than 2. Okay, so this time, again, you want where the shading and your function that you type in, a of x, b of x, or c of x, in this case a of x, intersect. So -2, -7, and 2, 5. So -2, -7. Again, always start with open dots. -2, -7. Then 2, 5. Look at your lines, right? Or your domain that intersects your function. If it's a dashed line, it stays open. If it's a closed line, the dots get closed. And then I like to get another point for reference. And all this does is just make it easier to draw your functions, right? The more dots you have, the easier it is to draw. And this is the function, a of x. I then type in my b function, or my b piece, b of x equals -2x plus 4. I then type in my domain restriction, 2 is less than or equal to x is less than or equal to 5. Again, find your points where they intersect. So 2, 0. -5, -6. Then look at the lines where they intersect. So the point 2, 0 intersects my b of x function, and it's also closed. So that means this dot is going to be closed. The point 5, 6 is a part of a shaded line, or excuse me, a solid line. So it's also going to be closed. And I don't have any other points for reference, so I'm just going to do my best to connect them. And now this is going to be b of x. Once you get it plotted, okay, it turns back to a simple domain and range kind of question. What I recommend doing is finding domain of a of x first. Now this is where highlighting or making note of your functions come into play. All right, I knew this when I just highlighted green was A of X because I made a note of that. If you have highlighters, color pencils, right, you can color them along the way. I think that personally makes it a little bit easier. Okay, so A of X, domain. Again, when I'm finding domain, I start off at the very leftmost piece of the graph. So I'm going to take a vertical line and go left to right until I hit a piece of the function. Well, I hit the function at that point right there. And again, I want the X value. So -2. It's an open dot, so it gets parentheses. Then I'm going to go all the way to the right until I stop touching the green. I'm only concerned with the green right now. So right there it stops. And it becomes 2. And I see it's an open dot, so it's also getting a parentheses. Then I do range of A of X. Again, A of X is still, I'm looking at my green function. This time with range, remember, I use a horizontal line. And because the smallest value could be negative infinity, I'm going to start at the very bottom and work my way up. So right there I touch it. That Y value is -7. So its minimum value is -7 and it's open. Now I'm going to go to the biggest Y value. So I'm going to go up and up and up and up and up and up. I'm past it, so I must go back down. And it stops right there. And that Y value is 5. The dot that this point is at is open, so it also gets parentheses. Once you do this for A of X, then you turn around and you do the same thing for B of X. If you have 3 functions, just go top piece, middle piece, bottom piece. Again, when I want to find domain, I'm going to use the vertical line. And I'm going to start all the way on the left. I'm going to move across to the right until I see where this line starts hitting the purple graph. So right there, it hits the purple graph at 2. It's a closed dot, so it gets a bracket. I'm going to move it to the right until I get to the end. I get right there, I'm at a dot, so that tells me I can't go no further. So I stop at 5. 5 is a closed dot, so it gets a bracket as well. If it was an arrow, it would go to infinity. And remember, if it points up or points down, points to the right, points to the left, that's going to determine your infinity type. Range, I go back to my horizontal line. Again, I want to start at the bottom because that will be the smallest possible Y value at negative infinity. And I'm just going to work my way up. Again, stopping when I get to where the graph touches the horizontal line. It touches right there at -6. It's a closed dot, so it gets a bracket. I'm going to continue going up until I get to the highest point. I'm not touching the graph anymore, so I go back down and it goes to 0. 0 is a closed dot, so it also gets a bracket. From here, I have this in interval notation. Domains, and going to go with domain. Range is going to go with range. And you just want to restrict or see if you can simplify this, right? Because the domain of f of x is really just functions a of x and b of x put together. So it will be -2 to 2, and then 2 to 5. And we had a similar question like this when we were simplifying interval notation. And remember, because I have a 2 here and a 2 here, they're the same. Because they're the same, they're duplicates. Now I want to see if I have a bracket or if it's going to have to stay a parentheses. So this 2 has parentheses, this 2 has a bracket. And remember, if you have a bracket, it overrides the parentheses. So -2 did not repeat. 2's repeated. So then I know it has a bracket. So then from 2 to 5. And you're going to kind of use the same concept with range. Range of f of x is your 2 smaller ranges we made. Just put together. So my smallest value here is -7. So it still must start at -7. -6 is my next smallest value. It has a bracket. Well, I could see -6 would be right here on this graph. And then everything past up to 0 is still shaded. So it's kind of contained in this inequality or this interval notation set over here on this side. 5 is the biggest, which is bigger than 0. So 7, 5 is my range. Now another way to think about this, guys, is to actually draw a number line if that didn't really make a whole lot of sense. And again, because I'm talking about y's, I like to draw vertical number lines. And I'm going to put a of x on the left, b of x on the right. Okay, so -7. I know 7 or -7 is less than 0. I'm going to put a dot here. I'll look at my, it's a parenthesis, so it must stay open, and then it goes up to 5. Put a dot here. It's a parenthesis, so it must also stay open. So I'm at this shading. I can then look at the range of b of x, which was -6. So -6 is bigger than -7. Look at my dot. I have a bracket, so therefore I can shade it. I have 0, which is also a bracket. And then sticking with my color scheme, I know my range is in between here. And again, you just want to pick your domain or range that's shaded, right? Your biggest pieces that are shaded. And that's all I have for domain and range of piecewise functions.